To prevent soil and sand erosion around bridge foundations, it's common practice to place stone riprap on bridge piers or abutment slopes. Even so, scour is the major cause of bridge failure. Case histories and surveys conducted as part of this project indicate that in about 5% of the cases, riprap-covered slopes fail. As part of the project, researchers with the Texas A&M Transportation Institute tested the filters commonly used between the riprap layer and the soil surrounding bridge foundations.
Bridge scour, erosion of soil around bridge supports, is one of the leading causes of bridge failures. So in order to protect against big holes around the bridge supports, we put riprap, those big rocks, around the bridge supports.
Even within our stone protection, we've seen, local and global failures. And so, what this research was aiming to look at is how can we influence the design of our stone protection to be able to try to mitigate some of these failures. And something that the researchers looked at really closely was the filter material between the existing embankment and the stone protection.
There are two types of filters. One of them is granular filter. The other one is geotextile. It's a fabric that we place under the riprap and over the sand or the soil in general, and that also prevents the sand from eroding.
So they looked at it from a literature review standpoint. They looked at it from a survey standpoint with the use of those intermediate filter materials. And then they also looked at it from an analytical standpoint. Long-term stability analysis using slope stability programs, as well as numerical modeling to kind of look at how slopes potentially could affect the critical velocity of stone protection. And the determination that they came to is that in all cases except for when we're placing of this material in an underwater application, that filter fabric from a cost standpoint and from an installation standpoint turned out to be the better option.
One of the questions in the project was how steep a slope can you have to put the riprap on top of it? And we found that if the slope is too steep, 1.5 to 1, riprap is likely to fail. But that 2.5 to 1 is the maximum you can allow and still have the riprap on top of it. And we found that when you start increasing the slope, then the rock cannot resist the same velocity. And this was one of the causes of failure in some of the case histories that we analyzed. So I think we should look into that.
For more information and to find the publications for this project, please visit the TxDOT Research Library at the link shown below.